Chapter 5 of your textbook discusses measurement errors, reliability, and validity. So this chapter begins by addressing measurement errors. Particularly is focused on what they are, as well as how to minimize them. So what are measurement errors? Measurement errors are errors that occur when the data we collect does not represent reality because of the way we are measuring them. So just a quick reminder, because this relates to material from chapter 2, some material that I know that some of you struggled with. So if you recall, you have a research question, and your research question has contained within it different constructs. And so ideas or phenomena that need to be conceptualized into operational definitions. And that's because these are oftentimes ideas, concepts, phenomena that can have possible multiple meanings and interpretations depending on who you ask. So you conceptualize them into operational definitions, which clarifies how, for your particular study, that construct is going to be seen, is going to be defined. And then you turn those operational definitions, you operationalize them into variables for all of the constructs that vary in your study. So that was material from chapter 2. So, you have kind of two activities that are going on there as you're kind of, before you even go out in the field to collect your data, you have that conceptualization and you have that operationalization. And so measurement error in particular is what happens maybe when we, operationalize our constructs in such a way that we aren't measuring what we think we're measuring. We're not really getting at what we're trying to get at. And so this doesn't always have to be a big deal. And your book emphasizes this. They note that measurement errors can be significant or insignificant. When it's significant, it is important because that means your data is flawed. You've collected, it turned out to be a really big misunderstanding error that has occurred in the data, and your data is now flawed, and therefore the results that you might make on the basis of that flawed data would be incorrect and inaccurate. However, if your measurement error is insignificant, it just means that, yes, this error did occur, but it ultimately does not influence the results. And you can kind of make this determination about whether or not it's significant or insignificant by calculating the magnitude of error in a study. And that kind of goes beyond the scope of our course. If you take later methods courses, you will learn more about how to do that. But what we will discuss in this course are types of errors. So primary kind of way of classifying our measurement errors is to determine whether or not it is a random error or systematic error. So the thing about random errors are they're inconsistent. There's no clearly discernible pattern. These types of errors just happen because people are people, they're individuals, and they can misinterpret a question for a variety of reasons. Like maybe they, were starting to feel rushed or bored. Perhaps at that moment, they noticed some annoying noise that was going on around them as they were taking the questionnaire. The point here is there is no discernible pattern, and therefore the error itself is inconsistent. It is random. And so if you have a small amount of random error, it doesn't necessarily impact the quality of the data. Now, the impact does become more substantial if a large number of people misunderstand a question. Like even if they are misunderstanding it in different ways and for different reasons, just the fact that a large number of people are having this misunderstanding does make it much more significant than if it was just, a small number of people. In addition to this type of misinterpretation, some random errors are due not because people misunderstand your question, but because they because of something that we call social desirability or social desirability bias, that sometimes if you're asking questions that are controversial or when people hold opinions that they feel like place them outside of the norm or outside of what is acceptable in larger society, even when you try to alleviate alleviate these types of concerns by, promising them, that their answers will be confidential, and maybe even trying to eliminate interviewer effects by, making sure that it's a questionnaire and not an interviewer. So there isn't even like a second person, asking them these questions. Even when you try to do that, there still just is some social desirability bias that comes into play here that can result in these types of errors. And these types of errors are still considered random because, once you try your best to control for them up to a point, you really still, there's no way for you to really plan how to address, a handful or a small number of people being like, oh, I don't want to share this data, or, oh, if I say this might make me look bad. And a good example of the first type of random error, the type where people might be misinterpreting a question, even a large number of people might be misinterpreting a question in different ways, was that test anxiety question example that your book gave. So they talked about how oftentimes people misinterpret, questions around timing, right? So that example from the book was the series of questions, variables. How often do you feel anxious? How often do you experience increased heart palpitations? How often do you experience a sense of not having air available when you think about something that worries you? And for all of those, it was never, rarely, sometimes, or often. But what's often mean? Like, often to me might mean daily, but often to you might mean once a week. So this is the type of question that might result in people misunderstanding their answer options, and that will introduce a certain amount of error into your data, because you don't know what people are thinking of when they answer often or never or sometimes. Now, as far as that social desirability one, that type of error that can occur, your book doesn't really give you too detailed of an example of that one. They mention how parents that are asked questions about like how often their children like consume certain medias, that they, even though we're asking them to answer honestly, in the back of their head, they're still concerned that, people might be judging their parenting qualities. So they don't necessarily answer truthfully, even though you want them to. So, the clear thing I think to take away from, random error is just that idea, though, that, it is consistent. There isn't a clear-cut pattern, which means it's hard for you to really catch it beforehand and address it. And then as long as it's not substantial, it doesn't necessarily impact the quality of your data. Now let's switch to systematic error, because as your textbook notes, it is a lot more problematic. So this occurs when a measure is systematically perceived as something else, meaning you operationalized it badly. That the fact that it's being systematically perceived differently than you hoped. So the example your textbook gave was the religiosity question. They asked the question, are you religious? And then they said, how often you go to church? And they provided the examples: daily, weekly, monthly, on holidays, and never. Well, the problem is a lot of different people can be religious. Not everyone goes to a church, and your book mentions that, right? You have synagogues, and you have imams, and you have other types of places of worship that are not referred to as churches. And so the fact that you did not use a more inclusive term in that second question, that second variable, instead you just said, how often do you go to church? You're going to get some people that say, oh, I'm very religious, but I never go to church. And you're going to be confused about what does that mean in your data. And that's what's meant by a systematic error, because that's probably not just going to be one person. It's going to be all of the people who are religious but not necessarily Christian. So that's systematic error. Your book also notes that systematic error can refer to the way we collect data, as well as other like environmental factors. And so the example that they gave about that in your book was actually teaching evaluations. So, they know that teaching evaluations, the later that they occur in the semester, the more likely students are going to be able to grade professors much more harshly, because they would have gotten back much more grades, as well as big grades, your test and major papers. And that asking a student to evaluate a professor after the student has received a poor grade has been shown to be correlated with the negatively evaluating that professor. And so in this case, it's not so much the types of questions you're asking, but how you're actually structuring the data collection, like when is it occurring, that results in this systematic error where all professors, the professors who are reviewed later in the semester, evaluated later in the semester, have harsher evaluations than professors who evaluated much earlier in the semester. And so that distinction between random versus systematic error is really all that you need to know in this course about measurement error. But to go back to this idea that, we want to minimize our measurement errors, because ideally we want our study to be as perfect as possible. We want to get to the real truth, the true answer to our research question, right? Because remember, we've asked a question that is an empirical question, a question that, ostensibly should be able to be answered by collecting data. And so, we want to go out there thinking, as long as we go about collecting the data in the right way, that we can get at this real answer. And this brings us to the other concepts that your chapter focuses on, the concept of reliability and the concept of validity. And so I'll provide like definitions of both, and then we'll talk about, how do we address reliability, and then we'll talk about how do we address validity in upcoming slides. So reliability is the consistency in our measurement. Keyword there being consistency. Our instrument is reliable if it will yield the same results even with different participants, or the same participants in different settings, and so forth. This means that the tool is being interpreted in the same way. It is an issue of clarity, if not accuracy, because accuracy refers to participants' answers about a topic and whether or not those answers are free from error, like, is this true? But reliability is less about, is this true, and more about like, hey, is this worded clearly so that everyone more or less interpreted it in the same way? While validity is the ability of your data collection tool to capture and measure the construct or phenomenon that we are interested in measuring. So this has more to do with validity has more to do with accuracy than reliability does. So the thing here is, are our measurements accurately representing what they claim to represent in order for our observations to adequately reflect the real world? So did we conceptualize and operationalize in such a way that we are accurately capturing the construct that we say we are gathering data about? So if this is confusing to you, I feel like the best way to remember it is this little image here. What is this? Like darts or arrows, right? Bullseye. So, reliable isn't necessarily valid. Like, so valid is the bullseye. You're hitting the truth. You're hitting the accurate depiction. Reliable is you hit it consistently. But what about if you consistently, your question consistently, is able to be interpreted the same way, but the answer that people provide is still not accurate, right? Then it's reliable but not valid. Yep, everyone is responding and interpreting it in the same way, but how they're responding and how they're interpreting it is not valid, and therefore you aren't accurately kind of capturing the phenomena you're interested in. If it's unreliable, meaning that your measure, every time you ask it of someone, they interpret it differently, they answer it differently. Well, the fact that it is unreliable makes it not valid, because you have, no way of knowing what the truth is here. What we're looking for in our measures is that they be reliable and valid, that they accurately kind of capture the phenomena that you're wanting to ask about, and that people consistently interpret your measures in the way that you want them to interpret. And so your book makes that same point, just without the use of bow and arrow pictures there. But it basically is saying an instrument can be reliable without being valid, but not the other way around. So instrument cannot be valid and also not be reliable, but it can be reliable but not valid. It can consistently give you the wrong answer, and yikes, that is scary. That is what we're afraid of in social science, because that probably means until someone catches that measurement error, we go around thinking that we are collecting valid data, that what we're collecting is accurately representing the phenomena because it's consistently giving us this data. But then it turns out we're wrong, and that's always a scary type of error to make. So now let's talk about how do you ensure reliability. 3 ways of doing this that your textbook discusses. The first is called inner observer, inner rater reliability. This one is much more common in qualitative studies where you have people doing things like coding interviews or observational notes or case studies. And this is also more common when you have like a group of researchers working on your study. And so your concern here is, because your data is this coded, this coded textual data, you want to make sure people are coding in the same way. And so you do this by having them keep separate ratings and then compare, because you're wanting to make sure that however they're employing the instrument, the coding instrument, that they're doing it in the same way, that they're being consistent. Then the second type way of ensuring reliability is through what's called test and retest reliability. And so the kind of key thing here is you really are interested in it over time. So you want to make sure that your data collection tool is consistently yielding the same results over time. And so you do this by comparing data collected at one time point with data collected at a later time point. Ideally, you do this by using the same group of participants. And as your textbook discusses, this way of ensuring reliability is meant to address if time or setting is influencing the reliability of the study, right? So, making sure that people, if they're taking it right before late lunch, and they're hungry and angry, that isn't making them interpret the questions that you're asking about, whatever, the quality of cafeteria sandwiches, like making sure that it is influencing that. And you might get at that by giving them the same instrument after they've already eaten lunch, or early in the morning, when it's nowhere near time for lunch. Because if they consistently, rate the cafeteria sandwiches the same, then that you've asked a good question, and your question is not being influenced by the time setting at which it's being given. So that's test retest reliability. And then the final type is internal consistency reliability. And so as your book notes, this is really common, particularly for questionnaire methodologies. But basically what you're wanting to do here is you want to make sure that participants truly understood the question. And so to do that, you include a few questions that measure the exact same variable. So if my variable was something like happiness, I might have a very straightforward question like, how happy are you today on a scale from 1 to 10? But just to make sure that I'm accurately measuring my concept, I might have another question like, do you feel blue today? Yes or no? Or I might say, instead of happiness, instead of the word happiness, I might say, are you filled with joy, right? The key thing is, you may structure your questions differently but you're asking about the same phenomenon. And if you want to even more easily identify consistency, then you'll try to use that same scale. So to go back to my happiness example, I might say, how happy are you today on a scale of 1 to 10? Um, I might then ask another question like, uh, how good of a day is it today on a scale of 1 to 10? Or I might say, how joyous are you at being alive today on a scale of 1 to 10? I'm literally making this up off the top of my head. So hopefully you're at least following my point, which is you're trying to capture the phenomena by asking about it in multiple ways. And that you can structure your questions differently, but if you give the same kind of response scale, at least, whether it's, a 1 to 10 rating, or, most to least likely, or yes, no. But if you make it so your response scale is the same, then it allows you to even more easily identify how consistent this is. And so, if your questions have similar or identical ratings, meaning regardless of how you ask it, people's answers are pretty consistent, we say that questionnaire has a high internal consistency reliability. If your ratings vary, right? Like when I asked about, how happy it was, you said, oh, it's an 8. But then when I asked, how great of a day is it, you said it was a 2. Now, of course, my questionnaire, the consistency isn't so great. And we refer to that as it having low internal consistency reliability. And so this just kind of is a nice little graphic, just kind of letting you think about, when we're talking about reliability, we can kind of talk about it in terms of stability, meaning that the response is going to be pretty steady over time. And we also can think about reliability in terms of consistency, which for that one, it's more about, is our measurement, is it consistently remaining the same? Does it look like we're getting the a similar response? Whether it is different coders in the terms of inter-rater reliability, or different measurement items, as it pertains to inter-item consistency. Now we have the different types of validity. So for different types of validity, we actually have a couple of these, or, I think more like 4 or 5 of these, beginning with face validity, which, it is what it sounds like, right? We accept something on the face of it. So how your book describes it is that a researcher or a group of researchers decides to classify a measurement instrument as an accurate measure of the construct in question without questioning or testing the tool. They just accept that it is. Like, okay, other people have used this, it seems to work well for them. We're not going to test it. We're just going to accept that it is a good measurement. So obviously this is a very subjective assessment, because you aren't objectively testing it yourselves. They mentioned that this is often used when we cannot confirm that a measurement tool is valid and we just need to move on with our research. And so this is widely used when people use secondary data, and they might not have access to the measurement tool, or even if they have access to the measurement tool, it's not like they can recollect the data because it is secondary data. Another type of validity is content validity. This refers to the extent that a measurement tool captures all aspects of the construct that is being tested or measured. Right. And so it is the idea, did you completely cover and address this construct? So, the example they gave you, the final exam questions. So if you're being tested on what you know about a course, and it's 50 questions, you probably would think it's pretty unfair if 40 of those 50 questions came from the material that you learned in the first week, because you would be like, okay, but then I had like 14 other weeks of learning things in this course, and I think you should capture that. And so, content validity, this definitely comes up when you're talking about constructs that are, constructs that contain a lot of maybe diverse ideas, and components that you need to address fully. You sometimes see this with how maybe people, choose to measure intelligence, right? Because, how you conceptualize it, it can be a very holistic term. There are a lot of different types and forms of intelligence. And so, content validity would be, if you creating a measurement that would try to address all of those different types of intelligence within that measurement. The next type of validity is construct validity. Construct validity is the degree to which a measurement is able to truly measure the construct in question. So this captures to what extent our operationalization is accurate. So how good of a job did we do? This is easier or harder for some constructs. That's just because for some constructs, the operationalization is very straightforward. Like age, whether you choose to, put it in age categories or, go by year of birth. I mean, it's just a very straightforward concept. But other constructs can be a lot more complicated. Like think about what I just said about intelligence, or even my earlier example about happiness. Those constructs are a lot more difficult and a lot more complex. And so, how do you know that you are measuring these complicated constructs correctly? And this is where your book really mentions that, this is why you have to do that literature review and really pay attention to what previous researchers have done, how they've measured a phenomena, because this is what you're calling upon in order to establish construct validity. You rely upon what's been done in past studies, and you make use of the literature to identify proven measurements and tools. And that's how you kind of make the argument that you're using a good measurement, because you can kind of point to how it's been successfully employed by previous researchers. Now, what about if for whatever reason you're not happy with how a construct has been measured in the past, and you're like, I can do it better. For my study, it's important that I collect this measurement in a different way than what other researchers have done. Well, this brings us to the final type of validity that your textbook discusses, which is called criterion validity. And this is a type of validity that you have to demonstrate when you aren't satisfied with how a construct has been measured in the past. So you're going to create a new measurement for that construct. So, how do you do this? How do you establish this type of validity? Well, you have to demonstrate two other types of validity in order to then say that you have criterion validity. First, you have to demonstrate concurrent validity. So this means that after creating your new measure, your new test, you compare it to how it compares with the old test, right? So, I might say, okay, this is how a person rated their happiness using this old happiness scale. I've created this new scale. Let's see if they rate themselves similarly using my new scale. Because if the ratings are similar across both tests, then that means that you have concurrent validity, that both tests are capturing the same phenomena to the same degree. Then predictive validity is what happens next, because after you establish concurrent validity, you then need multiple populations to continue to test the comparison between both tests, because you want to make sure that your new tests will predict behavior and results, that, you know, it wasn't just a fluke with those concurrent, when you were establishing concurrent validity, you want to make sure that your test works across multiple populations and multiple settings and so forth. And then once you've established predictive validity, like, yes, I can go out into other populations that, you know, haven't taken the other old tests, and my test will still predict, you know, how they feel, how they respond on certain measures. Then once you have that validity between the two of them, now you can say you have established criterion validity with your new measurement. And so this is just some charts, you know, that I think are very helpful, you know, to refer back to as you read over the textbook, as well as when you are later taking your tests. It just talks about what we've discussed, criterion validity, content validity, and construct validity, and just organizes that information in a different way, which might be helpful to some of my more visual learners. And finally, you know, I feel like I'm going to start offering you all more videos. They aren't required. There isn't going to be any material that's on the video that hasn't been addressed by my video or by the textbook that I will then test you on. But sometimes I know it's helpful to hear other people explain things in different ways and give different examples. And that's just what I'm providing you here. So some additional videos about reliability and validity, to help you become more confident about knowing and understanding those terms.